Hi, in the last session, we have designed a finite state machine project and we have used a PLL IP to drive that finite state machine. And we have also compiled our design. Now we will see the netlist viewer of this design. So we will use RTL Viewer tool and technology mode viewer tool to analyze our design. Okay, so let's move to the Quartus Prime software. Okay, so now I'm going to show you that how you can review your designs in more details in Quartus Prime software. And for this, we are going to use some very important tools of Quartus Prime. So first thing that I wanted to show you, that is Netlist Viewer. So for this, you need to go to this tools bar or tools tab. Now here you will see this Netlist Viewer option. And here you will see a few options. Like the first one is RTL Viewer. So we will look into this RTL Viewer, and also we will also look into this technology map viewer post fitting. So RTL Viewer will give you some high level overview of your module, and technology map viewer post fitting will give you some detailed overview or the detailed mapping of your project. Alright. So first I will select this RTL Viewer. So now this is our RTL Viewer window, and this is the high level block diagram of our top level module. So in the left, you will see the input part. So here you can see all the input ports are listed, and generally at the right, you will see the output ports. So for this module, you will see that we have reset as an input, clock as an input, and we have 3 switches as an input, right? And at the output, we have 3 LEDs. So now if you notice that all these 3 outputs are derived from the registers. Although you can see one register here in this block diagram, and you may think that this is one register that is driving these 3 LEDs, but that is not correct, because this register view is actually a combination of 3 different registers for 3 different LEDs. So if you notice at the name of this register, so that is LED 1, register 2 down to 0. So this is the name that is given by the Quartus Prime software. And if you look at our VHDL code, so that is our VHDL code. So here we have not listed any such register in our VHDL code, right? But still they appears in the RTL viewer. Like here, they are just appeared just before the outputs, right? And they are placed here because our LED outputs are derived from a registered process block. So if you look into the code, so that is our VHDL code. And if you go to the finite state machines where we are driving all of our LED outputs, so here you will notice that these all the LED outputs are derived at the rising edge of clock signal, and these are written inside the registered process block. And if you remember from our previous session, then I explained that if any output that is derived from a registered process block, then they are mostly derived from the registers. So that is why we are having these registers placed here just before the outputs. Alright. And these are actually 3 registers. So one is register 2, next is register 1, and third one is register 0. So these are actually 3 registers. Now if I come to this first block diagram or this first block of this RTL viewer, then I can see this PLL is placed here at the very start from the inputs, right? And we have instantiated this clock PLL as a component in our top level module, right? So if you remember that our PLL was having the 2 inputs and 1 output. So the one input is asynchronous reset and the another input is in clock 0. And we had one output that was the clock output of 25 megahertz, right? And that was named as C0. So you can see that this reset input is connected to the asynchronous reset of this clock PLL. And our input clock signal or our input clock port is connected to the input clock of this PLL module, and the output of this clock PLL is actually driving our internal logic of finite state machine, right? So this is actually a finite state machine. We will come to this little later, but before this, let's look at this switch input. So we have 3 switches as an input. So you can see that switch 1 we are having, then switch 2 and switch 3, all right? Now, if you notice that there are some lines, these are narrower, but there are some lines that are wider. So these wider lines are actually telling that these are containing multiple lines inside it. So for example, this line having 3 switches input, alright? Now one more thing, that if you select any line from here, then it will highlight all the traces of that wire, like from where it is coming and from where it is going, and from which components this wire is connected to. Like for example, this wire or this reset wire or this reset port is connected to this clock PLL. Then this is connected to the state machine, and it is also connected to this registers or LED registers, right? So it will give you an easy view of all the traces of any internal connections. For example, you can select this line and you can see that this C0 or the 25 megahertz of clock frequency that is connected to this present state, that is our state machine, and also that is connected to the LED registers, right? Now let me give a quick look about the Netlist Navigator. And this is our Netlist Navigator, and that is really important to use because this Netlist Navigator have listed all the components or all the elements including input ports, output ports, internal signals, wires, elements, registers, everything is listed here. So you can use this navigator to easily navigate all these things inside this RTL viewer. For example, if I select this ports view, then you will see these input ports and output ports. And if you remember that our module has clock input, reset input and switches input. Now because switches was STD logic vector and it has 3 elements inside it, so you can expand this view, and if you want you can select individual switches as well from here. Now if you click on any element of this navigator, then that element will be highlighted into this RTL viewer. For example, if I selected this clock signal, then you can see that is highlighted in the RTL viewer. Same way, if I select this reset, then that will be highlighted too. Now, if you go to this primitives, and if you wanted to see that how many registers you have used inside this module, then you can also see this. So simply you select this register section and you will see that you are getting 3 registers inside this module. And if you select this, then that section will be highlighted. And also you can extend this to see the individual elements of these registers. Now here we are also seeing this instances tab. This will be generally coming when you have used any component instantiations in your top level module. Like in this project, we have created an IP for clock PLL and then we have instantiated that into our top level module. So you can see that that instance has been coming here as a component. And if you expand this, then you will see this clock PLL that we have created or that we have instantiated into a top level module. Now you can also expand this. Now go to primitives, blocks, PLL1. So that's how you can navigate it. Okay. The same thing you can do by clicking of any of the module. And once you select any of the element or any of the port or signals, then it will be also highlighted into the Netlist Navigator as well. For example, if you select this reset port, then this navigator will also select the reset port here. Alright. Same for if you select the clock, then it is selected clock. Now coming to the finite state machines. So as I said, we have used finite state machines into this project, right? And Quartus Prime has already identifies that what we have used inside our program. So once I select this, you can see that state machine, which is named as present state, that is selected. And now you can also expand this view. So for this, if you double click on this present state, so this state machine window will open. And now this is telling you that your module are having 3 different states. So that is red state, next is yellow state, and next is green state. So if you are looking at your VHDL code, the same thing we have defined in our code as well, right? So we have 3 different states, that is red, yellow, and green, right? So that is visible in the graphical view here in the state machine. Now, if you look at the bottom section of this state machine, then it is telling you about the transitions. So what are transitions? So if you look at the 2 different states, so for example, this red and yellow, then you will see this connecting line. So this connecting line is treated as a transition. So that is telling that you can go from red state to the yellow state. And when you select any transition, then that transitions will be highlighted here. Okay. So this column is telling your current state. The second column is telling your destination state or target state. And the third column is telling you the condition that when your current state will jump to the next state. Means at what condition your current state will change to target state. So for example, if I select this transition that is from red state to yellow state, so that transition was happening when the switch 1 is pressed, right? So this red to yellow transition will happen when the switch 1 is pressed, right? Same way, if we look at this transition from yellow to green, then we have this transition selected. So transition from the yellow state to green state will happen when the switch 2 is pressed, right? Same this third transition, so that will happen when the switch 3 is pressed. So if it is pressed, then we will move from green state to red state. Also, we have one another transition, and that is called self transition. Means we are going from the red state to the red state in a cycle. So that is called self transition, right? Now, because we have specified that what will happen when the switch 1 is pressed, means when switch 1 is pressed, we will move from red state to yellow state. But we have not specified that what will happen when switch 1 is not pressed. So if switch 1 is not pressed, then we will be in self transition state, right? So you can see that current state is red, target state is again red, and that is dependent on the switch 1. So when switch 1 is 0, then this transition will happen. And that is repeated for all three different states. So that is repeated for yellow and that is repeated for green as well. All right. So this view is give you a better picture about your states and about your transitions, right? So you can use this view to review your finite state machine's results. So now I will close this window and I will go to the Netlist Viewer once again. So this RTL Viewer is giving the high level overview of your top level module. And now we will review our module in little deep. So for that, I will close this RTL Viewer window. Now I will go to this Tools tab. Now select this Netlist Viewer. And this time I will select this Technology Map Viewer Post Fitting. Alright, so simply click on it. Now this time you can see little complex view of your module. And this is the actual presentation which will be implemented in your FPGA board. Like these are the elements will be used, or these are the resources will be used inside your FPGA, and these are the interconnections that will be happening inside it. Okay. Now this left side view is your input ports and the right side view are your output ports. Okay. And now because this view is little complex, so this time it is more sensible to use this Netlist Navigator to navigate our elements inside this graphical view. All right. So let's look at the outputs first. So first we will zoom this area. So simply click your mouse button and select the area where you want it to zoom in like this. So you can see that this area is zoomed in now and you can see all the elements listed here. So we have these three LEDs as an output. Now again, once I click here, this also map these LED outputs in the Netlist Navigator as well. Okay. So you can see that we have three different registers here that is driving our three LED outputs. Now, if you notice, then these outputs are coming from the registers outputs, but also passing through the input-output buffers. Quartus Prime is also capable of adding the tri-state buffers here as well. But for this project, we do not need any tri-state buffer. So basically, this is our input-output buffer, and here these are acting as an output buffer. So that is OBUF. So this is for LED 3. Next one is for LED 1 and this last one is for LED 2. And all of these are driving from these three different registers. Okay. And we have seen these registers in the RTL Viewer as well. Now you can see that the input of these registers are coming from some combination logic, right? So these combination logics are either the combination of the basic gates or even they can be simple netlist or the fitters. We will come to this in some time. But before this, let's zoom out this view. So just simply right click from your mouse and select this, go to top level. So once you select this, then you will see this top level view. And now we wanted to see the input ports of this module. So same, I will zoom in this area. So I will click from my mouse and I will select the area where I wanted to zoom in. And now you can see that this is our input area. And here we have this clock input. And again, that is passing from the input output buffer before reaching to this clock PLL, right? Next, we have this reset input that is passing through the input output buffer, then passing through this clock control and then to the PLL. Next, we have these 3 switch inputs. Now till here, this is vector type, and the one element of this switch input is going to this input output buffer. So this input output buffer is for switch number 1, and similarly we will have 2 more input output buffer for these 2 extra inputs. So I can see that this is the input output buffer for switch 3, but I cannot see this input output buffer for switch 2 in this view, right? So what I will do that I will go to this Netlist Navigator, and now here you will see these buffers are listed for switch 1, switch 2 and switch 3. So when I select this buffer for switch 1, so it has selected. For switch 3, it has selected. And I wanted to see this for switch 2. So simply I will click on this, and now it will navigate to that input output buffer. So that's how easy it is when you use this Netlist Navigator. Now again, I will right click and go to this top level view, and let's zoom this area. So we have this clock PLL. We have already explained this in the RTL Viewer. So this is same, but this time what I wanted to show you is this combinational block. So you can see the expression for this combinational block here. But even if you wanted to analyze this combinational block, then you can also do this. So simply right click on this combinational block and go to this properties. Now once you click here, then this properties window will open, and here you can see, let me widen it little. So now you can see that this combination block that is named as selector 2, that is a combination of different AND gates, OR gates, XOR gates, etc. So you can see that there are 4 inputs that is coming in to this combination logic, and there is 1 output coming out from this combination block, right? And how these combination blocks are generated, you can see the graphical view of it. All right. Now the inputs of this combination block is named as data A, B, C, D. And if you wanted to know that what are these names and how these ports are connected into your top level module, so you can see them in the bottom section of this properties window. So for this, you will select this fan in, and you will see that data A is connected to selector 00, data B is connected to selector 01, and same data C, and data D is connected to the switch 3 input, right? So if you select this, then you will see that is connected to the buffer or the input output buffer of switch 3. All right. Same thing you can see for the outputs. So your combination output is connected to this present state dot green. Now if you move this little, so you can see this present state dot green. So that is a register that is generated for the green state, right? Similarly, if you wanted to see the relation between the input data and the output data of this combinational block, then for this you will get the option of truth table here. So you just simply select this truth table, and now you can see all the combinations between the inputs. So these are 4 are your inputs and your output. Okay. Similarly, you also get the equation view. So here you can see that this is the equation for this combinational block. All right. And these are your input datas. Now, if you remember from our previous sessions from the FPGA basics, then I have explained that how CLB works in the FPGA. So inside the FPGA, they are created based on the lookup tables. So these are basically the CLBs used inside the FPGA. All right. Now again, select the Netlist Navigator. So here is the tab for Netlist Navigator. So I will select this. Now this time, if I select this present state dot green, so you can see that all the registers are listed here. So we have 3 registers generated for the states, and we have 3 registers generated for the LED outputs. So these 3 registers are for the LED outputs, so you can see, and these 3 states for the present states. All right. So from this view, you can see that how many registers are used in your project, how many input output ports are used in your project, and how many elements or different elements are interconnected to meet your requirements for your project. So this is really an important view to understand if you are working in VHDL designing or Verilog HDL designing. Okay, so that was our RTL viewer and technology map viewer for this finite state machine project. And next we will be looking at some important reports that is generated by the Quartus Prime software. And this is really important to understand these reports for better designing. So for this, first we will look onto the fitter reports. Okay, so let's close this window from here now and jump back to the Quartus Prime software. Okay, so that was our RTL view and technology map view of our design. RTL view gives a high level structure design, and if you want to drill down, then you can use technology map post fitting tool to analyze your design. We have learned that how the Netlist Navigator is useful to navigate between different elements used in your design, right? Now, next, we will look into some very important reports that are generated by Quartus Prime after the full compilation of your design. So, stay tuned for the updates, and I will see you in the next session.